Cool. Out of the way. Move you guys out of the way so you can see what I'm doing. My notes. All right. So we're actually going to get rid of this main class stuff here. We did have fun with the car yesterday, but we're actually going to start. I'm going to push this car into a different package. Actually, no, I'm going to keep it here for now. We're going to talk about packages, I think, later or tomorrow, or sorry, Thursday. Next code. But right now, I was going to create the bank classes now. So let's do another one. We're going to get the default behaviors. Bank account. Well, bank account class. Don't ask me again. I don't like to do those. I do that all via terminal. So again, I mentioned before, I don't like using the integrated get stuff because I like using the terminal. It makes me feel geeky. So I like using the terminal. So if you use the built-in get behavior from IntelliJ, I'm not opposed to it, but it's good to have that terminal knowledge. It just one definitely also looks a lot better in an interview if you know the commands for get from the terminal. So highly recommend going through that process. I don't use the built-in IntelliJ get pieces. Anyway. All right, bank account. So the first thing we need to decide are what are the fields or attributes of a bank account, any bank account you have that is shared between all accounts. It's like checking accounts, savings accounts, investment accounts, CDs, 401ks, loans, all sorts of bank accounts you can have. They all have certain items that are all the same, that they all have, or certain fields that they all share. Give me at least one. Let's start with one. Most common ones.
A balance.
All right, every account has a balance of some kind, right? Have it. And one thing we're going to do is I'm going to use int balance. Now, there's a reason for this, and some of you might be like, well, it's money. Why not use a decimal, right? Why not use a float? Well, in computers, and this, I'm going to try to do a quick version of this one. Decimals are tricky. So here's the thing. Everyone knows what binary is, right? We know what binary is. Ooh, hello, Chang is in. Nice. Or Chang came back. We all know that. Let's do this one. We all know that that's what binary looks like. Does anyone actually know what number that is?
That's 5.
Yes. So the idea is that you actually have positions. So the ones position, the twos position is right here, and this is the fours position. So it's they're the power of 2. So 4, this is the 8th position, 16th, 32, 64, 128. Now, if anyone's been familiar with worked with computers a lot, these numbers are probably sounding kind of familiar, right? You've heard of these numbers before, 128, 256. Are those numbers kind of sound a little familiar? Does anyone know what the next number is? 512. Any of these numbers sounding familiar?
Like
Yes.
What's that?
megabytes.
Yeah, you think like bytes, megabytes, and RAM, right?
Yeah.
Yeah, there was no random magic to those numbers. Those numbers were because of the whole binary system we used. Those numbers were based on the binary system, whereas what we use with computers. All your computers, again, I'm going to get this one a little shorter than normal. All your computers, even though you can interact with them in multiple ways, they actually, if you boil them down, only have one input into a computer. There's a single input into your computer. Those in cohort 8, you probably already remember this, so don't answer. Does anyone know what that one input is? Look at your computer you have right there. Look at your desk, look at your computer. Look for an input, a single input. Give me any input that you think is like, you know, this is an input. Mention it.
Like a charger or a headphone jack? Is that what you mean?
Oh, like it's a headphone jack, charger. I said one. There's one input that every computer requires.
The power button.
Keyboard?
So the keyboard is an input, but it doesn't work unless you have the other input, which I think someone else just mentioned.
Power cable.
Yeah, the power cable, right? Your keyboard doesn't work without power, does it? So yes, a keyboard is a type of input, but it still is reliant on the power. Same with the mouse, same with other devices. It still relies on power to work. So everything is based on that idea of whether or not there's power. Actually, when you press a key on a keyboard down, you're creating a circuit which allows power to pass through, which is the symbol for 1. 1 was the idea that, hey, there is power. You have a connection. The lines are connected, which used to be represented by just like the number 1, which looked like an L. This is a horrible font to use my syntax, but anyway, that was the 1. The 1 was the idea of the electricity is connected, the circuit is closed, we have power going through. 0 was the idea of there is no connection, there's a lack of energy, there's no energy passing through. So in the beginning, we could just say yes or no. Someone's like, we need to do more with this. We need to do more. Well, we realize that we can count, right? We have the ability to count. And so what we decided was we can use binary, which is there's 1. We use just a quick idea of a binary. Decimal, you have the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are your symbols for the decimal system, right? When we start counting at 1, we get up to 9, and when we get to 9, we like, okay, well, I need to add to it, but I've already used 0. I've already used that symbol, so I can't reuse it because now 0 is 0, right? Well, what do I do when I want to add 1 to this? What do I do?
You make a 1, 0.
I roll this back to the 0, and I add another 1 over here. I add a 1 to the other position. When I get to 9 again here, and I add 1, I roll over. This one goes up by 1, and this one goes back to 0. We do the same thing in binary. Just we have a lot less symbols to work. 0, 1. Well, now I need to add 1 to this so I can get to 2. Well, again, I'm out of symbols. So what do? I roll this back to 0, and I add 1 to the next position over. So, hello. Right? It's not gonna. Just deal with it, Java. It's okay. I know what I'm doing. So again, we do 1, 1. That's your 3. Well, again, I had the situation where I want to go up another number. I'm out of symbols here, so I roll this number to 0. I need to increase the second line though, but I'm out of symbols, so I roll that over to 0, and I add 1 here. Oop, I don't know why that went to the new line, but whatever. Not that, that. And that's my 4. And that's all binary is. We're just using 2 symbols. Actually, if you really think about it, there is the ability to do a unary number system. So we're talking about binary. Does anyone know what the unary system is?
Like
That
counting
can't
with
be
your
one
fingers.
number.
It is
It's
one
like
number,
Greek-
yeah.
It's like
What's
with
that?
dashes.
Yeah.
Was it the
1,
Greek
2,
dashes?
3, 4, 5. 1,
that's it.
2, 3, 4.
Oh, numerals.
Yeah, there's no numbers. There's a single
Roman,
digit, the
sorry.
1. We're just using the 1. I just turned one of the ones on its side as a shortcut for humans. But the tick marks, is your number system for an unary number system. Every time we need a number, we just add another. We just count up the number of ticks. That's your unary number system. Almost stopped the share. Clear my drawings. There we go. So going quick with that. So now we have the idea of there is power, there isn't power. Now we can count. We can do numbers. That's useful. Right? We got that. Well, okay, well, we got numbers. Well, we can do math, I guess. That's great. But we want to do more with a computer, right? There's a lot more we can do with it. Otherwise, it's just a fancy calculator, right? Well, we didn't realize that anyone ever sent a message to someone where you used numbers instead of letters? Where 1 was A, 2 was B, 3 was C, and so you created this encoded message that you handed to a friend.
It was like World War II code breakers type stuff.
Yeah, well, that one's a very easy one. People can just guess that one. But the idea, yeah, you could represent your letters as numbers, right?
Yeah. And
so we decided that, and some of you may have heard of this before, but we have this tool called ASCII, the American Standard Character. But I keep forgetting the I's. So if someone wants to Google it quick, you can let us know. But we have the ASCII, which is a outline of all the characters that we need in the alphabet, as well as also any special characters on a keyboard too. So like the enter key, the new line character, dots, periods, numbers, exclamation points, all those symbols we need. So we have that. Now we have letters. I'm not going to go into too many details about that. So we have all the characters we need. We now have letters. We have numbers and letters. We can now type things. We can send messages to people. We can at least write up documents. We can print things. That's useful. Again, we're still just thinking with the idea of is there or isn't power, 1 and 0. Well, I want to do more. Well, let's think about it for a second. Well, if I think about it for a quick second, what is color on a screen? What is color?
It's red, blue, and yellow, and it's just a number of how much red, how much blue, and how much yellow you have. So either you'll have
Close, yeah.
Like
that was color for paint. Yeah, that was color for paint, and we realized that light is similar to that. It's not red, green. It's not red, blue, yellow. Light is what? What are the 3 colors of light? RGB, right?
Yeah,
yeah, that's what I was thinking.
Yeah. red, green, blue. That was the only trick. That was the only switch. But yeah, we
What-
had
what
that
is-
same idea. So red, you said red, blue, yellow, which is the colors of paint. All good though. It happens. People do that. But yeah, RGB is our colors of light, and a pixel on our screen is going to use light. So we have 3 lights, and if we change the amount of light on each color, we can make different colors. We can make different shades. Like, well, let's see. How can we represent that? Well, we decided, you know what? Actually, we can say 255. We have that ability because we decided that in a system, a byte has 8 values. So I have the keyboard disabled because I apparently am doing annotation. Nope, that doesn't fix it. Let's do that. Go away. There. 1, 2, 3, 4, 5, 6, 7, 8. This is a byte, all 1. The funny thing about this, anyone know what number this is?
155.
Yeah, that's where the number comes from. So the number 255, there's a reason why we see that number all over the place. Why we see that number 255 when you do your RGB stuff is because that is a full bit. Sorry, full byte. A byte, all ones is the number 255. That's where that number comes from. So we say, you know what, 255 is 100% of the color. All zeros is that color's turned off. That light's turned off. And so we're like, you know, if we use 3 of those, we can represent a bunch of colors, right? Tons of colors. 255 times 255 times 255. That's how many colors we can represent. So now we have a dot of color, which is cool. Well, I can make my text look different now. I can make my text have different colors. Cool. Well, what can I do with multiple dots of color though? If I do multiple dots of color, what can I do with that?
Mix them.
Well, there's that. I can mix them into what? What does that do?
Mix more colors.
Well, there's that, but more accurately, what I'm looking for is I can make pictures now.
can draw.
I can draw a picture now.
Emoji.
I can make pictures. I can put a bunch of dots on a screen of different colors and I get an image. That's all a picture is. A picture is just a bunch of dots of color that just happen to look like something. So that's useful. Well, now if I think about it though, if I take multiple pictures in a row and just kind of put them in a row and make slight changes now, what does that do? I don't know why I put a nose for my slight change, but whatever. I'm not an artist, never claimed to be.
Videos.
That's my wife. Yeah, video, right? Video is just a bunch of images that are played at a certain speed. And sound is just, well, if you think about sound, what's sound? How does sound work?
Waves.
Yeah, they come in waves, and there's math for waves, right? We can use math to represent waves, right? Numbers can represent waves. And we already know, well, we can do numbers. So now we have sound and moving video. So now we definitely have straight up movies now, right? Well, let's see. Well, here's the thing. Now, if I can take a movie, though, and allow the person watching it to press a key and change the movie. So if they interact with the movie and they change the movie, what's that?
Video game?
Yeah, it's a video game, right? You really think about it at base level, a video game is just a movie you're interacting with. Yet we're still just asking, isn't there power? So the very next time you ever go to, if you ever put on a virtual reality headset and start fighting alien robots or whatever it is, remember that boils down to just, is there or isn't there energy? You just keep building on little by little. So, very cool stuff.
I have a book for you.
What's that?
I have a book for you. I'm not sure if you might have read it because you're using a lot of the examples that come from it, but
Maybe?
it's this one.
I don't know that. I have to look it up.
It's really good because I never understood binary. I just couldn't. My little Cassie brain was just like, what do you mean base 2? Like, what are you talking about? I have 10 fingers. Like, I count on my fingers. Like, I'll admit it. But yeah. So
I'm going to give you guys a little evil trick you can give to your friends nowadays. This is a joke that only developers, well, mostly only developers or math will understand. Let me know when you get it.
oh, I've seen that on Mug.
Fair.
We're getting it. We're figuring it out. So yes, those who don't understand binary see this as there are 10 people in the world. Those who understand binary read that as there are 2 people in the world. So now you can mess with your family members with that and write that on something and have them be like, that doesn't make sense. So you're like, yes, that's exactly why it makes sense. I'll have to definitely send me that book. I'm interested now.
Yeah.
But the main reason I pointed this out now is how, based on what I told you, if we needed to store the number, let's say the number 20, we could store that in binary, right? We understand how that works, right? We can look at it and say, okay, well, let's see. I showcase this as the 1, 2, 4, 6, 8, 16, 32. I think that's all the numbers I need, right? 1, 2, 3, 4, 7. I need one more, right? Yeah, 32, 64. We have all our bits. We needed to create the number 20. We needed to store it in binary. How would we do that? What would that be? Well, this is too big, right? So that'd be a 0 there. What about the 32th bit? Would we use that one to represent 20? Too big, right? All right. What about 16? Is that small enough? Yeah, we can use that one. So we use that, and now our 20, we only need to be able to store the other 4. Well, if we look through, we know that 8's too big, so nope. 6 is too big, nope. Wait, I did this wrong.
It is.
128. Nobody called me out on that.
Just going with you, man. Ride or die.
Yep. I appreciate that. Don't blindly believe me. I can make mistakes. I am human. There we go. So we have 0, 128, 64, 32. There's our 16. That's our 8. There's our 4. There's our 2. And there's our 1. There's the number 20 in binary form, right? Well, now if I wanted to store the number 20.35, how do I store that in binary?
You don't.
Now
You
I get the
cry.
confusion, right? Now I see the confusion. Like, wait, I don't know how to do that, do you? And that's the thing. Computers have the same problem. Decimals are not really something that computers can really comprehend. It's difficult for them. There are ways to do this. If you had to store this in some way, what could you do? For example, you had to throw some random idea out there.
Could make you could represent the value as a fraction of the
Do that.
intended use for it.
Yeah, you could do that.
I know that's what I did for mine, at least.
Oh, you actually tried that. Yeah, like I could store 20 and then store 35 separately and just know that 35 is the decimal portion and 20 is the whole portion, right? Store them as 2 separate integers and just, add them back together later on. So that's one thing I could do. But again, it's like I'm not storing a decimal though, am I? I can't store a decimal in binary. It doesn't work. And that's what a problem that computers have. Computers have something called imprecision, because at the same point, we have to think about how many decimals can I have? How deep can I go with a decimal? Or how the terminology is, how precise can I be with a number? Go on forever, right? Yeah, that's the thing that a computer can't really comprehend or understand. So computers have something with decimals known as imprecision. So there's this large recommendation to not do decimal math if you can avoid it. A lot of newer languages now, you don't have to worry so much about it, but this is why a lot of times you will see people storing things as integers if they're easy to switch. And well, we can store money as an integer, can we? We can refer to money as a whole number. We don't have to do money as a dollar, right? How can we also count money?
Talking about different currencies.
Well, cents,
Oh,
right?
okay.
If I say I have 100 cents, what do I have?
$1.
I have $1, right?
Dollar,
But I can
dollar
say
bills,
I have 100
y'all.
cents. So I can store my money as cents in the system so that I can do integer-based math. I don't have to worry about having to do decimals, multiply by decimals, or divided by decimals, have to deal with imprecision of a computer. And having to have a computer try to figure out how does it do decimal-based stuff when it doesn't know how to do it. So this is why you'll see a lot of times decimals being stored as integers and then being formatted into decimals when they need to be displayed. Following along so far? I think we went a little bit on a rabbit hole there, but it is good to know this because it shows, again, if you know about imprecision, it can be very, very useful. If you really want, No, I was actually going to think I was going to go with something else. Never mind. Don't listen to that one. But yeah, imprecision is important. Knowing about it is key, and knowing that you should store decimals as integers if possible, then do it. There's actually a lot of videos out there that talk about how imprecision has caused issues. We've actually lost rocket ships because of imprecision, because we actually weren't able to handle the decimals and the precision level that a rocket needs. Rockets need high precision, and so our computers weren't able to handle it, and we actually lost a couple of rockets due to that. So fun. They say it's not rocket science. Well, apparently it is. So. Int balance. All that to just say we're going to store our money as integers. What's another field we can do for banks?
Banks or bank account?
Bank account. Thank you.
Name.
Yeah, probably the name, right? Who owns it, right? We'll call it owner. Account owner. Anything else you can think of?
Pin.
Pin. Well, we could do that, but I don't really think we use a pin for a bank account. We tend to use a pin for a card, right? So we'll hold on to that. We'll save on that. What else?
We need a account number.
There we go. Yeah, we have an account number, right? And store it as an int. There we go. Int account.
So why as an int and not as a string?
That's something we could do either way. We could do numbers, or we could do other ones. Depending on if we're going to do math on it. That's the key item. So that's actually a good thing that someone brought that up. I was curious if anyone would. Yeah, this is definitely something we're thinking. Like, are we going to do math on this at any point?
I would think not.
Probably not. We're going to most likely just use it as a display method, right? A display system. So this is something you could definitely argue should be a string. That way we don't have to worry about accidentally performing math on it. We can just make it a lot easier just to print without having to typecast it as a string, right? So yeah, we're going to store this as a string. That works. And I'm going to bring in one more because it's going to benefit us in the child classes. Our type. What type of bank account is this? This is going to doing this specifically because there's a reason for the child class. This is where the child class is going to take advantage of this. So with that, let's build our constructor. I'm going to have four fields. That's all we need right now. I'm going to start with that. We might add more later, but for now, let's start with this. So let's build our constructor. Balance. And string type. And we're just going to set all of our class variables, or object variables, to the values that were sent to the constructor. We do this just because the whole reason we have these match what we send in, just because it makes our life a little easier when trying to pair up the items. So it's easy to just say, okay, well, this dot balance equals balance, and I don't have to try to remember the order that I'm getting them. That would be a semicolon. This dot account num equals account num, and this dot type equals type. Straightforward. Why is that yelling at me? Oh, no.
Oh, because it's bank account.
Bank account.
Thank you. Right. There we go. Thank you. So we got that. And then I can think of two methods that definitely belong in a bank account. There's two things you can do with any bank account that no matter what type it is, you can do. Are there some restrictions on them? Yes, but there's definitely two behaviors we can do on a bank account.
Deposit.
Yeah, deposit can definitely be one, right? So public void deposit.
What do we want to make that private?
Well, we do want to make sure that that's publicly available to actually perform the act. Now, we might decide to put some behavioral protections in place to say, well, you only deposit if you have enough, right? So we could put that in place. So if, that's actually a good point, if amount is less than, greater than balance. Actually, no, let's do this. Less than or equal to balance. We actually do it. So if our amount is less or equal to balance, we'll perform the withdrawal. Or sorry, the deposit. Wait,
No, that's a deposit. We don't need to.
Yep, no, we don't care. So in this case, yeah, I don't care. I can deposit money into my wife's account all I want, even if I'm not on the account. I can go to the bank and be like, hey, I put $100 into this account. But like, it's not yours. You sure you want to do this? Yeah. Okay. Very rarely do the banks really stop you from depositing money into someone else's account. Okay, this is not yours. You realize you won't be able to get this back, right? I'm like, yeah, I get it. Which I've done before. I've deposited money into other people's accounts before, so that's not a problem. They really don't restrict you that much. So we're just going to do balance is equal amount. Straightforward, right?
Negative amounts.
Wait, why? Oh, true. We do want to make, we could do that. That's something that could be, that's the hacker mindset. And I like that. So think about how can I break my program? Well, this is not an unsigned int, is it? Which means it can go negative. I could get a negative amount here, which means I'm now taking out money from that account, isn't it? I can cheat the system. I could have left this in, and that would be considered what's called a vulnerability. It's unintentional behavior based on how we coded it. We didn't intend for people to be able to withdraw money using the deposit system. But if someone calls the deposit method with a negative value, now they're taking money out of the account. So I could put some logic into another class that calls this method, deposits a negative money amount into it, and then that siphons off money, and then I can just deposit some money into another account. And now there's no trail of where that money came from. It's just I'm now siphoning off funds. Someone in the kitchen. Anyway, yeah, you just might want to make sure that first, if our amount, we can do, well, either way we can do if that's greater than 0, we'll perform the action. Otherwise, do nothing. And I don't have to type anything in because it's a void method. So if the amount is greater than 0, we'll run it. If it's not, we just won't change the balance, right? So if it's 0 or negative, we do nothing. That makes sense? Sound good? Cool. Next method. What's the opposite of deposit?
Draw.
I think I saw, yeah, I saw Chelsea's guy, and I think it was Chelsea, right? Yeah, that's the coffee place, Chelsea. Getting names. I'm working on them, trying to make sure I got them. So yeah, that's how I say it. But yeah, there's somebody else. I don't know who actually said it with the unmute active. But yeah, withdraw, right? Click, void, withdraw. Unless we want to do the same thing that I was about to do in deposit because I got the two confused. We want to make sure we actually have enough in our account to actually do the withdrawal. So first, if our amount is less than or equal to our balance, we will do it. Balance minus equal amount. Now, yes, there is this idea that maybe we should add some sort of approval system or some sort of validation that the person is allowed to make the withdrawal. We can always add that into the bank class or into another system later on. So it doesn't necessarily have to be here. We don't have anything here that says it. We could, I guess, say is we could ask for, let's say, like the owner's name and make sure the owner matches our owner. So you could get a string owner or a requester. We could compare that. There's more logic we could do here. And that's what's key about this is adding in those items here. And this technically is kind of like a setter, right? It's acting like a setter. We could say set balance, but we're separating these so we can have different logic. And that's why it's important that our balance is private. By making sure our balance is private, we have to have these methods and we have to have logic inside of it. I guess we don't have to have logic, but it's kind of required in a way. It's good to have the logic. And this is where we're going to do this. That's why I haven't created any getters and setters for any of our items here. There's one last method I want, and this is one that you put in a lot of classes at the beginning for debugging, and this is some sort of print method, some sort of display method. Let's do that override string again. So we'll do that one since people actually know about that one in this group. Override. We also found out yesterday that this is an optional flag, which was kind of cool to find out. But again, the main reason we do this is because it's going to let us know if we are or are not actually overriding a parent item. If we type in a method that doesn't exist, so if I do public display stuff, with that void, this does out hi. Note how the method isn't angry. The method's fine. There's no errors on this, but the override is upset. And the reason it's upset is because it's going to tell us method does not override a method from a superclass. It's noticing that this is not a method in the superclass, so just letting you know, this isn't actually overriding anything. And that's the benefit for you of this override flag. It lets you know if you are or not overriding something. So let's now change this though to string to string. And I'm just going to, for the moment, do return double quote. You can see it. If I get it wrong. Oh, yeah. There we go. So now notice that the override flag is gone because every object has a toString method that we can now override. Every class you create, every method, every class you create inherits from the class called object, and they all have this toString method in it. So you can always override it. And in this case, we're just going to do a cool little feature here. We're going to do, what did I say?
Cliff, what is the purpose of overriding the toString method?
Mostly it's just because the main reason to do this one is because a lot of developers know that a toString method exists. So it's a nice friendly method that you know is there that you can use to get a string variation of a string version of the object. So it's just a convenience one. We could totally, instead of doing an override, we could simply just do a void display details and do a SL and print out what we want. So we could do that. But since we know that every single object that we create, every single class, is inherited from the object class, it all has the toString method. There's a default behavior that the toString method has. By overriding it, we can tell it to display the way we want. So that's why you'll see some people using it. In your class, I didn't bring it up in the beginning because I wasn't sure if it was necessary, but because it's not one of the, to me, I didn't think it was actually that well used, but this group, one of the people in here already brought it up yesterday and talked about the toString method. So that's why I introduced it to this group. Someone else brought it up first. Normally I was actually going to bring it up for your class a little bit, actually very soon. So in the interface abstract class system, we talk about it because we're getting more into the overriding and dealing with more inheritance. Thank you. There we go. My brain. So that's all. Yeah, so in this case, we're going to kind of, I just want to make sure we keep on top of what we kind of already introduced. So override object string to string return. Again, the only difference here is that with the toString method, we do have to provide the system out, and whoever calls it with a display details, we could put the system out inside the method. In this case, we'll do this. I'm going to do type I think that's good. Yeah, type owner and balance. Don't really need the account number. I guess we could show it if we wanted. Yeah. Throw it over here. We'll throw the account number in just so we know that it works. And for sanity check, does anyone know what this /t is doing?
Tabbing.
Tab.
I heard a couple people say it. Tab, right? It's like hitting the tab key on your keyboard on the terminal. So that when it gets to this point, it's gonna act as if you hit the tab key. So it's just gonna give us some nice spacing. Let's create one of these and see what it looks like. Why is this yelling at me? Oh. Hey, Hector made it. Nice. Semicolon. Always important to have that. But we have that. Now let's head over to main. Here we go. Over here. Hey, Hector. The good news is we are recording, so you'll be able to watch later the first part of the video, or the first part of the lesson that you missed.
Okay,
Cool.
got it.
Try to see what you can glean from just watching it. So, our main class, we actually need to go ahead and create a bank account. And so this is one of the benefits right now of having an active class. We can instantiate the bank account to test it out. So, I'm going to do bank account. Bank account. Let's start a balance at, it will give us $1,000, which means I have to do 2 more zeros because that's not $1,000. That's what? How much money is that?
$10.
$10.
Yeah, that's only 10 bucks. So give ourselves 2 more zeros and get that $1,000 in there. So we got $1,000 in our account. The account number, no, that's owner next, right? So owner next. Who wants to own a bank account with us, with our bank?
Phil.
Phil. All right, we'll go with Phil. We'll use a PH Phil. All right. Next up is the account number 1234, and our type. We'll call this a checking account. And I forgot this would be a string. Cool. I'm just going to do my account dot to string. So of course I have to surround that with a S out. Right. Print it, then we'll do a my account dot deposit, and I'll put in, give ourselves 10 bucks. Then print out again, S out, account dot to string. Then go ahead and withdraw to make sure that works. We'll attempt to withdraw $100. That again. I'm actually going to copy and paste it just to save you guys some time in the lesson. Now what I'm going to do is I'm also going to try to withdraw way more money than I have. So let's withdraw a whole bunch of money. And this should not work. So we should see our balance not get touched. We should probably add a system out in our withdraw method to say it failed, but for now it's fine. Oh, I was going to print out the thing again. Nope. This. So you can see it didn't actually withdraw it. So let's go. Running. There we go. Type checking, account num, owner, balance is our 1,000. We added the 10 bucks. We withdrew the 1,000 and we did not withdraw. So no money was withdrawn. So we see our method seems to work, right? So far, so good. Let's create our first child class now. Now let's do our first inherited child class together as a group. I'm going to take a new class. We'll start with the simple one, the checking account. And the first thing you do
Go back to the, I'm so sorry, could we go back to the bank account class?
Of course.
The owner, is that actually being set?
Oh, wait, you're right.
Oh, yeah, you set the
Dang it.
property capitalized.
Good catch. I didn't see that. Yeah, no, you have null there.
That's
Good
all.
catch. Nope, you're right. Yep, I had capital O owner on line 9, so double check your code to make sure that's not doing that. If you see null there, that's why. If you don't see null, then you coded better than me. Awesome. Good catch. No, I didn't even see that. Awesome. So I don't need that open anyway. So we got our checking account now. So the first phase of doing inheritance. Who knows the key word we need for inheritance, for the is a relationship?
Extends.
Extends.
We go back to bank account real quick.
Of course. If anyone has any bugs, actually, no, let's do that first. If anyone has any bugs, let us know. We can always look at it as a class and do some debugging.
Yeah, I have a bug.
All right, let's take a look. I'll kill my screen for a second. Go ahead and share yours. Let's see what we got. You see, I had a bug in mine, so anyone can have a bug.
You gotta
All
disable.
right. Yep. Enabled. All right, take a look. So does anyone else see the problem? I technically did type what he typed first, so didn't notice when I switched.
Yeah, the T in two string needs to be lowercase.
Yeah. I messed that up too. I actually typed the exact same thing, so I'm not surprised you had it. You probably just missed me changing it. I did it quick. So let's run it and see if it works. Why is your run button not enabled?
Yeah, mine's not either when in main. It's weird.
Click on main for a second. Oh, there it goes. Oh, weird. Okay, maybe you clicked and I didn't see it. Never mind. There it is. That looks good. Checking 1, 2, 3, 4. Fill. There's our values. Good typing. Now I gotta say I actually typed toString with a capital T first. You probably just didn't notice me and shrink it.
Cool beans.
One, yeah, nice. All right, share screen. Go. All right. So we're gonna extend the bank account. And right now that's gonna tell us right away that there's a problem. The problem is bank account has a default constructor. And so that means our checking account needs to have a default constructor that will trigger bank account's default constructor. So let's start there first. So I'm gonna do public checking account. And we at least need the data that the bank account needs, which means we need a balance. We need a string. I think we did owner first this last time, so I want to keep it the same order. And we need a string account number. And technically we also need, string type, right? Yeah. And I have the A here capitalized as well, so fix that. But here's the funny thing here that we, why is that yelling at me now again? All right, because I thought I actually called super. So I'm just do super and send those items over. Balance, owner, which I think actually for a second there, it actually showed me that I can just save myself some time. Yep, there we go. I can do that, right? So here's the strange thing about doing this. Isn't this a type of banking, type of account? Checking account is a type of account, right? So why should I expect the main system to tell me that's a checking account when I already am one? Every single account here should be string checking here, right? I actually don't need to accept it as a parameter. I can just hard code in and send that from the child class. So the child class doesn't necessarily need to accept every single thing in its constructor that the bank account has. All it needs to do is provide bank account with all the data it needs. So as long as I provide bank account everything it needs, I have satisfied bank account's requirements. So I don't have to have all the same stuff in the actual constructor's parameters. A little helpful item there, showing how that works. So that's one of the key things to keep in mind. Just because the checking count needs 4 items doesn't mean my constructor has to accept 4 items. Some of those items the parent class may need might be static values of the new child class. So that's a key item there. That can be very useful. So you got that. So yeah, that's going to qualify what we need to do to make this a bank account. So let's give it a unique item. What's a unique field? I talked about a couple. What's a unique field we could give it?
A debit card.
You could give it that for the time being. Yeah. But technically, I guess the only question I get to ask is: a debit card restricted to just a checking account? Well, as a withdrawal account, I guess, as the payment account. Yeah, we could do that. Problem is, we're actually going to create a debit card class later. I'm going to pass on that one. Sorry, because there is a plan to create a debit card class. That could just cause us some annoyance later. Another unique field that we could do for checking account.
I'm pretty sure they have pins, right? Each one has their own pin.
Again, that would be the debit card would have the pin, not the checking account.
True, yeah.
Right. Unless you have enabled phone-based banking, but even then it's usually the client that has the pin, not the account.
Limits
I
on how
mean,
much you can spend.
technically oh, sorry, Arneal.
Sorry, I'm so sorry.
I was gonna say technically the checking account would have a different account number, right?
What do you mean? What do you mean?
Each accounts have their own accounts and
Yeah.
routing numbers.
Yeah. Which, again, we're not setting this, the bank account is not separate anymore. So we wouldn't create both a checking account and a bank account. The checking account is a bank account. So just all it's doing is getting all the parameters and fields, all the fields and methods from this item here. So it's going to have all these fields and all these methods. So when we create a checking account, it's not going to create a new, like 2 accounts. It's only going to be 1. Good question. That helps me to make sure we understand how these work.
Yeah,
good to answer questions. So I think Arneal had a good idea though. What were you saying?
We can limit how much we can withdraw from the checking account
We could do like a daily limit on our withdraw. So we could do a private daily limit and make that an int. And so what we do here is do private int daily withdraw. Keep track of how much we've withdrawn that day. Daily withdrawn. And of course, we need to have something that would, of course, reset this once a day, which we're not going to implement all that logic, so don't worry about that. We're not going to keep something that's going to track it, but it's good to have. I actually like that because what you can do here is now I can put in the daily limit here, daily limit. But I'm not going to accept daily withdraw as a parameter, am I? I'm just going to set that starting value at 0. And that's going to change as we do withdrawals. I'm going to increment that as we do a withdrawal. And that, let's do this dot daily limit equals daily limit. So now for the unique item, let's create a reset daily withdraw. Let's do that. So we do a public reset daily limit or daily withdraw. Void. We'll do that first. And this is going to do daily withdrawn. All right, so to do that. Oh, it's not inside the brackets. Close 0. All good, right? Simple, straightforward. And now what we need to do is we need to make sure that when we do the
Why
withdraw,
didn't you put the daily withdrawn in the constructor? And you made it. Why did you put it in the? Why didn't you put it in the constructor? And why did you make it basically another constructor for that one variable?
this is not a constructor. This has a return type, and it's not the name of the method of the class. It's not a constructor. This is just a method that can be called.
So why didn't we put that daily withdrawn in that?
Sure.
Because it's already set to 0.
Correct, and that's something you can do. So there's 2 places you can set the starting value of a variable. You can either set the starting value where you declare it, or you can do all your settings in the constructor. There's no performance benefit out of the 2. The only thing I could argue is that I don't know if Java has this. I know other object-oriented languages have this, that you can do what's called a reinstantiation of an existing object. So you can reinstantiate an object which would rerun the constructor. And in that case, what would happen is that if this was done here, daily withdrawn won't get reset when you reinstantiate it. If this is inside the constructor, it does get reset when you reinstantiate. So I don't know if Java has the capability to reinstantiate. I don't remember if it's C# or Objective-C that has it, but I know there's an object-oriented language that allows you to reinstantiate existing objects. So you can kind of reset them. And that would be the difference between setting the value here in the declaration or setting it inside the constructor. So in this format though, since we're not going to be worrying about reinstantiation, there's no benefit to putting it in either spot. Just make sure to be consistent. That's all. It's a good question though. Good question. Next up. All right. So the next thing we need to do for this one is to make sure that our withdraw method actually increases our daily withdraw. Well, we already have a withdraw method, don't we? Now here's a good interesting question. Do we have a withdraw method? Does checking account have a withdraw method?
Yes.
No, we just have a withdrawn variable and we have a reset daily withdrawn method, but we don't.
So the individual class doesn't, but technically it does because it inherits from bank account who does have a withdraw method.
No.
Yep, there you go. So it technically does because of the inheritance. So checking account is inheriting a withdraw method, but we want checking accounts withdraw to behave differently. And so we can do that via the override system again. We've already done that before with the toString. So we're going to override the withdraw method. Yeah. And with this, we're going to do a couple things. First thing is, are they already over their withdraw? Or will they go there withdraw? So if daily withdrawn plus withdraw, amount greater than our daily limit. Shortcuts are weird. We're just going to straight up return and do nothing. Don't withdraw, don't touch it, just return. We'll probably throw an exception or put out a system out, but let's do that actually. This can be better. Put out some error messages. Limit. And then we'll just do return so that it stops running all code. Like we talked about before, that way we don't have to do an else here and keep moving forward. Sound good? Now this, if we aren't going over our daily limit, we actually don't want to do the withdraw until we, well, dang it, I want to use the original method, but we have nothing that'll tell us whether or not I successfully withdrew. So you know what, we're not going to worry about it too much. Again, we're just going to do it. So in this case, we're just going to assume that the withdrawal works, even though there's a chance that we might not have enough, but the attempt, we're going to count the attempt against our limit. Just in this case, because we don't, there's nothing in the bank account superclass that will tell us whether or not this is or isn't successful. We could change this to a Boolean that returns true or false to say it was successful or not, but I don't want to deal with that right now. I want to keep our stuff simple for the moment. It's something to keep in mind. So all we're going to do now is I don't want to have to rewrite the withdraw method that is in our parent class. So what I can do is I can just call super amount to actually call the super withdraw method. Why is it yelling at me?
Sure.
Oh no, sorry, super dot withdraw. Right. I can just call the parent's method to say, okay, I did my unique stuff. You can now do the normal behavior now. So I did my check. I can actually withdraw. So go ahead and run the standard withdraw system now.
But why did we use super with the withdrawal?
So again, once we confirm that we are allowed to withdraw because we haven't hit our daily withdrawal limit, why should I have to recode this? I shouldn't have to retype that, should I?
No.
So all I'm going to say is, you know what? Okay, I confirm I'm allowed to withdraw because of my withdrawal limit. So now I'm just going to call my parent's withdraw method to say, okay, now do the normal withdrawal behavior.
Okay, so we're using super to call the parent class.
Exactly. Super is how you refer to your parent, to your father or mother. That's how you call back to your parent class and say, hey, run this. Sound good?
Yep.
Cool. Okay, so got that. Let's do some more tests. I'm going to change this now. We're checking here to a checking account here. Oh, I got to change this too. Checking account.
Cliff, I have a question.
Yes, go ahead.
I saw in Mosh's videos that he was, instead of using the class type, the declare class, so bank account, new bank account, he was using var in place of the first bank account.
I see it a lot.
What is your take on that?
var has certain spots where it's good to use. We will talk about when those points are, but in a lot of cases, it's actually more professional to be what's called a explicit developer. So you want to be very explicit with what your variables are. Using var, you're letting the compiler decide what the data type is. It's still gonna pick a data type. You're just letting the compiler decide what the data type is based on the context versus you, the developer, picking it. So you're kind of leaving it in the hands of the program to decide what data type it is. By being explicit, it's confirming that you know exactly what's being put in there. You know what's getting put in there. So,
got it.
Yeah, it's when you use var, it says use everything on this side of the system to decide what data type it should be. Usually, this will tell it. And in this case, it's not such a bad idea. It's not such a bad thing because you do see it twice. So it's not too bad. But we'll actually talk about the main spot where it's 100% allowed and actually looked as this makes sense. It's useful. It's definitely beneficial here. See it in a not too far from now. So one of the very, very soon items we'll actually see it. So for now, yeah, you'll see me do a lot of explicit typing, which is I will always, very, very rarely use var. Just because, yeah, it's good practice to showcase you know what the computer's doing and you're not relying too heavily on the compiler or on the system itself. You know what's going on. It's kind of what you're trying to show off with. So, you're going to see any performance problems? No, because again, the compiled result will run the same. The compiler will actually replace, if I put var here, the compiler will replace that var with bank account. So as far as the finished code is, there's no difference between me typing bank account or typing var. So, yeah. I prefer to see the actual data type name. It's going to look better. It's going to be more clear. I don't have to search through the line to see what data type it's going to be. I can see very specifically what it is. I prefer that. And usually in a lot of interviews, it looks better. But throwing out a var every once, if you're trying to save time after you showcase you know how to do this, is fine. Good question. I actually couldn't remember how much var Mosh used. Couldn't remember how many times he
He
did it.
pretty much uses it every time he
Oh God.
has something like that. Yeah, that's why I was asking.
Yep.
Because it became like he wasn't, whenever he was doing a new instantiation, he was pretty much using var.
Yeah. I don't like
At
the look
least
of it.
in the intermediate and then in the advanced.
You might have been doing that also to save time after doing enough videos. It's
Yeah,
nice to
he
save time.
explains it, but
Yeah. Like I said, there are two types of developers, and this is only going to be based on your company. They might be perfectly fine with var and actually prefer it. If that's the case, use var. But explicit programming looks better and definitely has an easy, for me, it reads better. So that's what I see. So that would be my justification for it. Definitely base it on the company. And if you get to look at some sample code from them, that can help a lot. Like if they have you look at some code to go look for errors, use that as your guideline. Oh, I see a lot of vars in their testings. I'll go ahead and go for more var. Code what looks good for the company. Cool. Good question. Let's go ahead and do this. Yeah, I want to change this to a checking account. Checking account. Actually, no, let's keep that actually, now that I think about it. We're going to keep that one. Yeah, let's keep that actually. I'm just going to add another one. So the checking account. I'm going to change this over to a type account so we know the difference. Okay. So again, we need the balance. We'll do this one at $200, so there's not a lot. Who's owning this one?
George.
Chelsea.
Chelsea?
Or Chelsea.
I heard Chelsea. We're giving Chelsea an account that she doesn't want. Don't worry, we're not an evil bank, I swear.
We're Wells Fargo.
Oh, crap. I spelled that right.
She'll tell you.
I did. Yay. The account number we'll do 9876. And we don't need the type, but we do need the withdrawal limit, which is going to be, we'll say we have a 100 withdrawal limit a day. And we can withdraw $100 a day. And forgot that's supposed to be a string. Withdraw $100 a day. Oh no, $1 per day. I just realized. I can withdraw $1 a day max. That was great. So yeah, $100 a day. There we go. All right. Let's go ahead and print it. So we're going to grab this one and just do a change the my account to checking. Let's go ahead and do a my checking. We're going to go ahead and do another deposit, make sure that actually works. Deposit again, well, $20 this time. Okay. This time, let's do a my account dot withdraw. I'm going to withdraw $50 to start. That's not our limit, so this one should be allowed. And then we'll try to withdraw another 60, which will put us $10 over our limit. We'll have that amount. We will have the $60 in our account, but it should deny us because we're going to be over our limit. This time we should actually get a printout because we added a system out this time. So checking. $60. Let's see. Play it. Let's take a look. Did I not do the system out? I thought I did. Why did that not display? Hold on. Let's go through.
You start out with 10.
So there's. Oh, I didn't display it. Hold on. One. I didn't display the new one, so we don't know if it actually worked or not. But wait. Looks like this one didn't work either. So hold on, let's go through it. So Chelsea starts to do that at 200. We then deposited 20 bucks. We did not withdraw the 50, which is weird. We got to figure out why that didn't work.
Bro, can we go to checking account real quick?
Yeah, of course.
All right. Can we go back to main? We can go back to main.
Well, we're also looking at it too. Okay,
Oh, okay.
not that. There. Oh, I'm dumb. My checking got withdrawn. So this was allowed actually. It will be if I actually ran it again, but I didn't run it again. But okay. So start at 2,000 or two. We started at $200. We add the $20 to it. We withdraw the 50. We still withdrew the 60 though. I know why we did. Anyone know why that didn't work? Why that still worked? Why we didn't hit our limit? So I checked the limit, but what did I not
You
do?
didn't actually modify the daily limit withdrawn.
Forgot that. So we need to actually update our daily limit to actually add in that new amount that we just put in so that it actually keeps track of our withdrawal. And this is what I was saying. We're going to increase our daily withdrawal, even if this withdrawal system here fails, even if we try to withdraw more than we have, we're still going to track that as an attempt. And so that's what we're going to do on this system. That even if you attempt to withdraw more than you have, that's actually going to affect your daily limit. It's just how our bank works for now until we improve our code. So let's try that again now, and let's see if this now fails. We don't want to be able to withdraw the money. Let's take a look. There it is, our error over limit. We got our error message that we wanted. We're told we're not allowed to withdraw that, so we could try again on our main. Let's go ahead and redo this time by saying, okay, well, let's try a $40 and see if that works. Run it. We get the error over limit, and then we actually withdraw the 40. All good?
Can you go back to your checking account, please?
Of course.
Thank you. All set. Thank you.
So what we're going to do on Thursday, we're going to do two things from Thursday. We're going to review the idea of building out maps. Do you want to do that yet? Yeah, we're going to do that. Okay. So we're going to do that. But we're also going to have one of you guys actually help me code the savings account. So on Thursday, when I create a savings account, we're also going to create an investment and CD account. So you can actually see what's called a grandparent, parent, child class. So we have an investment account, but investment accounts kind of cover, there's a lot of different types of investments we can do, right? There's CDs, there's stocks, there's bonds. There's a bunch of different types of investments we can do, right? And so investment account is kind of, again, another kind of vague account, isn't it? So we can have the general investment account, but then we can also have a CD investment that inherits from investment account. So investment account inherits from bank account, and CD invests from investment. And so we can see how that works when you have this multiple levels of inheritance. How does that work? Sound good? So again, your challenge now to keep working on is keep practicing these items, keep going through the videos. That's really the important item that you're working on right now. But now using this, try to come up with, take your current accounts that you built and see if you want to modify your accounts at all. Modify your checking account in attempt, if you really want. Here's a good challenge. Create your own idea of what you think the investment account and the CD investment account might be. So you have your investment account, which is going to inherit from bank account, and it's an investment account. And then your CD account is going to invest from investment account, which is already inheriting from the other one. So try those out and see what you come up with. Those we may or may not review, but the main thing, like I said before, attempt what we're going to teach so you can see where you do or do not understand things. You have questions ready for that day. So when you attempt these yourself, you'll already have questions ready for me on the day of class, and whether or not I do touch base on those items, you'll be able to ask them. Before we end, any final questions for what we did today? Let me do this.
A general question about
Please do.
private versus public when we're defining our attributes just beginning. Is it super common to start just making them private? Because so far in class, we've been doing it private for the most part.
Yeah, I thought, yeah, for us, and one of the things I like is I prefer to start private because that means that everything is secured at first. When things are
Okay.
public, I have to remember to make them public. So let me actually show something now that I want to showcase quick. Yeah, let me just do a quick little mini item. Let me make balance public for the time being. And I'm going to create a very fake kind of debit card for the time being. So actually, no, we'll do a fake investment. We'll do that. Oh no, no debit. We'll do debit. This is going to be a fake debit card class. It doesn't inherit.
Are we coding this along as well? Or no?
I'm moving quick on this one because we're going over
okay.
time. I just want to show something really quick on that. Maybe we'll do this on Thursday, actually. No, hold on. We'll do it fast. Because what happens in here is that at first, that doesn't look bad. The idea of balance being public doesn't look bad right now. There's no issues with it at the moment. But this debit card, yeah, I could take in a debit account, but what I can do now is do a charge. Not a good example, actually. I've heard of the better one, but public charge that accepts a checking account. This one, I would just do the account charge, but also do like, void charge account and amount. Normally there would be some sort of pin system as well, but I'm doing this quick so you don't see it. So what I do now is I have that account, and normally what I should do, which I don't want the capital A there, fix that. What I should be required to do is to run the withdraw method and put in the amount, right? That's what I should have to do in order to affect the account that I'm giving. Because balance is free, what I can also do if I'm a malicious developer is I can also do, you know what, account.balance equals account.balance minus, I'm just gonna take out 50 cents out of this account. And then I'm gonna have some sort of code that will alert me that it happened. Alert myself of the removal. That I can then go and add that money to my account on the back end. Now, here's the thing about that. If this is, let's say, Christian's project, Christian's building this and he hires me to create this debit card class. Now, his GitHub, he has these saved and tracked. They're all good. And he's only expecting me to modify this file. So I go through, I write a whole bunch of code. This is way longer than it is. I send it to him. He skims it. Yep, this looks fine. Submits it, right? Because there's nothing odd yet. It doesn't seem anything odd. He's expecting me to modify this file. He's expecting me to modify this. So now I've injected a vulnerability into the system that I can now exploit. If his checking account or bank account, sorry, is correctly set with this is private, if I want to set this system up, I have to go to this other file and change that now to public. When Git, that's going to now flag. Christian's going to see, hey, Cliff, why did you modify bank account? Oh, hey, why did you make the balance public? Why did you do that change? He then comes over to debit card and says, hey, Cliff, what's this? Why did you do that to my code? What are you doing here? And it makes him more alert that I'm doing something that I probably shouldn't be doing. A lot of times, public items are where you find vulnerabilities in systems. This is how hackers get in or modders get in to parts of the program they shouldn't get into because your abstraction or your encapsulation isn't solid and insecure. For me, if you start everything public, you have to remember to switch everything over. If you start everything as private, then when you need access, if you realize, okay, I need access to this thing, well, I could just simply make it more accessible. It's a lot easier to make things more accessible than to try to secure things that you're already accessing. Because as soon as you saw, if I make this private now, after I'm already using it somewhere else, I have to go to all those locations that now are using it and change them.
Okay.
That could get really annoying once I finally realized that this shouldn't be as public as it is, but I was using it as it was public. I'm making it private. I try to use it. I get told, okay, well, this isn't public yet. Well, let me decide, should I make it public or should I make a getter? So in this case, now I'm looking like, okay, I need access. I want access to the balance method, the balance field. Should I make it public or should I use a getter? And this is why I like to go private first. So if I try to access something that's private, it gives me this alert and it prevents me from accidentally making vulnerabilities in my system. Makes
Well,
sense.
yeah, I was just curious because the majority of the tutorials are online, always use public attributes.
Yeah,
Touch
it's
on
easier.
protected, but they don't ever use it in the walkthroughs.
Yeah, and that in a lot of cases you'll see a lot of those what I like to call like easy practices because they're easier and they don't have to explain as much. By everything being public, they don't really have to dig too deep yet into what private, protected, and public are, what they mean, and there's less of them having to jump over and make something public that was already private. Which is something you might see here. We're gonna, if we ever want to access one of these things, we now have to stop ourselves to either create a getter or a setter or to change it from private to public, which slows this down. In tutorials, it's easier if everything's just public because then you can just do whatever you want and get through the lesson a lot quicker. I also see that a lot of times. I think, what was it? One of the students, we were looking at some of the examples we had. One of the students had a bunch of getters and setters, right? I think that was Cassie. I showed that. But even in cohort 8, one of the students there actually did that recently. One of our students, I think it was Evan. Evan did it, where he had this habit of, every single item he had, even though it was private, for every single attribute or field, he would create a getter and setter for it. That had, all it did was either return the item or change the value. Which is like, you realize that you should have just made everything public then, right? You're not really benefiting from the private keyword. And so he admitted, like, oh, there's just a lot of tutorials told us to do that. Like, again, yeah, it's easy for them to do that. It's an easy system and it looks good as a way to explain getters and setters. My goal for you guys is to show you the better practices, keeping security in mind and performance in mind. That's one of the key items we want to make sure you have when you go to the interview, is not just understanding how it works, but also thinking about performance and thinking about security. Especially because one of the companies we have you going to, or at least 2 of the companies we've worked with, are both financial institutions, eMoney and Citizens Bank. Those are both financial institutions. And security in finance is big, if you didn't know. So having that kind of thinking about security, abstraction, and encapsulation accurately is going to help you a lot in the long run. So the videos you guys watch, those are introducing you. I'm going to polish it. Sound good? Yeah, please ask these questions, by all means. Good questions, loving it. Let me go ahead and kill that now. We don't need that. I'm gonna get rid of that because we're gonna create a better one later. So delete. Git commit. Be sure I clean up. Okay. Push. And the main reason why I put these certain commits in there for anyone who needs to. GitHub again. Thank you. No.
Cliff, have you ever broken a key on a keyboard?
On laptops, yes. On laptops, yes, because they don't have mechanical keyboards, so they don't click, and I have to hit them harder to make a click sound. So I will, if you ever actually see me or work with me when I'm typing on my Mac keyboard, you will feel bad for my Mac because I will tap on the keyboard in a hard enough way to make the keyboard make a sound.
I felt bad for my laptop when you used it.
Yeah.
I kind of wanted to cry.
Yeah, I'm not nice to my Mac keyboard because they make it so quiet because they want it to be sound. They're all about the experience and not about the benefit of the actual performance. But that's just my personal preference, and I'll do that to a Windows system too. That's not Mac specific. That's anything that if the keyboard doesn't make noise, I'm such a blind typer. The noise lets me know that I hit the key and hard enough to actually trigger the syntax or trigger the actual activation of it. So when I push down the keyboard enough, I hear that click, I feel the click, and it tells me that I hit the key enough. And when I don't have that sound, I end up tapping the key so that I know that I hit it hard enough. But this is also why I do it. So if you go to here, if you ever want to go back to a previous point, you can just click on commits here, and you can go back by using git checkout, this number right here. And the code will actually revert back to a previous state. So you can actually follow along the video again at that same time. So this would be the end of our first class. This would be the end of today's class. So you can always use these to get to the end of a certain class. We just go to the previous class's item from that video, and you'll be able to grab the state of the program at that time so you can code along. Sound good? So that's why I do these very specific comments for you. All right, I think that's good. Any other questions? Right, so I look forward to coding with you guys on Thursday then. Like I said, you guys are going to help me create the savings account, and then I will go ahead and have us work on investment and CD. I'll see y'all then. Keep up with the videos. If you're stuck on anything, let us know. I'll see y'all then. Take care.
Later. Have a good night,
Bye.
everybody.
Bye. Thank you.
I will see Titus and Neil in the other group.